if it is okay, I will go for an example. Hello. I will go for another topic called as hello. Today's new topic is resolution. Okay. Yes, I have to start from here. Yeah. Shall we go? Hello. Hello. Yes, I'm not getting. Yes, yes. Thank you. Could you please tell me my screen is okay for you? Could you please respond through voice messages, because my screen is large. I cannot see your messages.
Yes, sir, it's visible.
Yes, thank you. In the previous class, we are discussing about entailment. Na? I have discussed about this word. Okay, 2 minutes I will discuss about entailment, and I'll go to new topic. Okay, I think if it is okay for entailment, I will go for a new topic. What is entailment? What is entailment? I have told you that if we take a set of sentences, yes, if all the sentences are returning true, okay, are you getting me? If all the sentences are returning true, then if we infer the same rule for a new sentence S1, if this sentence is also returning true, then we can call this S1 entails. Yes, entails is nothing but simply a simple line. You look at here, relationship between two sentences, such that if the first one is true, the second one will also be true. Okay, if this is true, if we apply the same inference to the second sentence, this will also become true. So I will call this as entailment. Okay, S1 and S1 entails yes. So we have started a small discussion with could you please 1 minute? Okay, please. Yeah, 1 minute, students, please. Sorry, my parents are in the hospital. Hello, shall I continue?
Yes, sir, you can continue.
Sorry. Yes, just 2 minutes, I will brush up and I'll go to new topic. Okay. As per our Wumpus world example, knowledge base can be represented as KB. Okay. Entails a sentence alpha if and only if alpha is true, then all these knowledge worlds, whatever the worlds are there, if the worlds are true, then alpha will also be true. This we have represented as alpha entails KB. This is our last class. And I have shown you one simple example. Okay, directly I'll go to example now. For example, if you take here, this is called as 2-1. Okay, this is if agent is here, if you take a pit here, if you take a pit here, or if you take a pit here. Now, whenever there is a pit, agent feels the breeze. Okay, whenever there is a pit in 2-1, agent feels breeze. Okay, whenever there is a pit, there is all alternative adjacent sides will get a breeze. Now we are getting a breeze from here, we are getting a breeze from here. So agent cannot go here, agent cannot go here. The only solution is he can go back. Okay, for example, if you want to represent these 3 pits, we can have 8 possible models or 8 possible environments. Now in DLD also, if you take 2 variables, 0, 1, we can have 4 possible, 0, 0, 0, 1, 1, 0, and 1, 1. If you take three Boolean variables, 0, 0, 0, 0, 0, 1, I think Gopalakrishna told about them. Okay, if you have 3 things, you will get 8 possible models. So here I have 8 possible models. Are you getting me? Now we are asking the machine to where there is a pit. Okay, now wherever there are 3 question marks, we are representing with 8 possible models. Now we will see in the out of 8 possible models, what are the best possible models. Okay, this I have considered as 8 possible models. Now we will see out of these 8 environments, what are the best. Now if you take carefully, now this is called as 2-1. Okay, this is called as 2-1, this is called as 2-1. That means we can call knowledge base as Ompus world rules, whatever the rules which we have discussed while discussing about the giving the Ompus world example. I have discussed so many that if there is a pit here, all the adjacent sides will get a breeze based on the rule. Okay, and agent cannot go in a left or right direction. He can go only left 90 degrees, right 90 degrees, straight. Okay, he can go only these 3 directions. Agent cannot go in this way. So we cannot take this as safe condition. We cannot take this as safe condition. This is not safe because there are pits. Okay, so the only possible solutions are, we can take only this is possible environment and this is possible environment and this is possible environment. So I have represented this as knowledge base, and as per our observations, if an agent is in these 3 environments, he is safe. So if KB returns true in these environments, now if I consider this environment as alpha, this is also safe. It is also returning true. Now I can represent that 1, 2 is safe in alpha. Now if the knowledge, if the agent is in these 3 environments, he is safe. And if you take alpha is now in these 3 environment, the agent is becoming true. Now in alpha 1 also it is returning. So I can call alpha 1 entails KB. I will wait for 1 minute. Now any doubts, you please ask me. I will clarify them. If not, I'll go to next case, alpha 2 case. Hello?
You can go to next case.
Yes. Look at here. Yesterday I told you that you should check whether the agent is safe in alpha 2. Okay, please. Now, if we look at a simple thing, is it called as 2-2? Is it called as 2-2? Is it called as 2-2? Now, look at here. Now, if I take 2-2 is safe or not? If it is safe, I will say that entailment. If it is not safe, I will say that alpha 2 is not entailment knowledge base. Okay, a simple example. Look at here. If you take this entire thing as knowledge base, please, if you take this entire thing as knowledge base, if I take this environment, is it true? Is it safe if the agent is in this environment? He will be need answer from you. Now we are in 2-2. There is a pit. Is it safe position or not?
No, sir.
Now, if it is not safe, what we have to do is alpha 2 not entailment knowledge base. Clear? Now, maybe in the example, they may ask you either 3-1 or 4-1, or they may ask you to find out whether the knowledge base is entailed or not in the examination. You may get in the mid examination or you may get in the final examination. They will give you the positions like this. Okay, they will give you the positions like this, and they will ask you. Otherwise, they may ask you this position. This position may be 3-3. Okay, whether it is safe or not. Okay. Now, can I go for entailment, true or false? You have to write the rules and you have to show them. Okay. Now, this is up to here. This is the last topic. Now, shall I move?
Yes, sir.
Yes. Now, let me go to discuss about what is a model for 5 minutes, please. If you understand this diagram, we can do more slides very easily. For example, look at here. I have taken a set of sentences. Please observe carefully. If I take a set of sentences, now all these set of sentences are returning true. Okay, here I had a known to be true. For example, if all these set of sentences are returning true, now I'm creating a decision machine. Okay, I'm creating a robo, or I'm creating an agent, and I'm getting a program. Okay, now this my program or my machine, my robo, I will call it as decision machine. Okay, or I will call this as knowledge base KB. Now, if I take a new proposition, or if I take a new sentence, please listen carefully. If I take a new proposition, or if I take a new sentence, I am asking the decision making machine, is it true? Whether the sentence is true or false. Okay, I am asking this machine the truth value. The truth value may be either true or false. Now, what this decision machine will do is, the decision machine will take the sentence and it will infer with all these sentences. Okay, and it will return either true or false. Now, this is called as inference mechanism. Okay, are you getting me? This is now we are asking the machine same thing we will do in machine learning. Okay, now it will return, the decision machine will return whether a new sentence, it can be either yes or no. This is called as truth value. Are you getting me? I will wait for 1 minute. Now I will call this decision machine as model. If you understand this, what is a model, then I will go to the definition of model. I will go to here. Is it okay? What is a model? Okay, first we have to create a model. That model will otherwise I will tell you what the definition of machine learning. Observe carefully. Definition of machine learning is a two-step process. Okay, first we will train a machine. Okay, first now in Robo movie also Rajinikanth has created a machine. Okay, maybe it took several years to train a machine. Okay, are you getting me? He created a machine. Then once the machine has trained, then the machine has taken over the things. The machine has loved the heroine, and the machine has done several jobs. Now the machine learning two-step process. The first step is, first we are going to create a machine or train a machine. Then the machine, all the inferences will be done. Second step is, all the inferences will be done by the machine itself. Now if you give a new sentence or new proposition to this machine, the machine will think that it will use its knowledge, it will use it, and it will return either true or false. The same thing my decision machine is doing. Earlier I have created a model. That model I called as a decision machine. Now it is going to return either true or false. Now if I give a new proposition, it will tell you either yes or no. This I will call it as binary classification in machine learning. Binary, that means it is returning either true values, either yes value or no value. It is returning only two. If it is returning three values, either, for example, if I give a digits 0 to 9, if I ask my machine, deep learning machine, if I give an unknown machine, unknown image, is it a image 7 or is it image 6? Now I have several machines. Now it may return 0 or it may return 1, it may return up to 9. There it is called as multi-class classification. If your model is returning more than 2 values, that you will call it as multi-class classification. Okay. Now I need some information, Amma. Hello. This is not there in the textbook. Just to understand the definition of a model, I am discussing all these nonsense. No response from you.
Yes, sir. You can continue, sir.
No. One thing. What you understand about a model? What is a model? From this diagram, if you understand what is a model, then I will give you the definition.
Sir, basically, when we first we'll give a set of instructions, sir, it will follow.
Yes. First we will give a set of instructions. That means first we are going to train a model, train a machine. Okay, that machine we are calling it as model. Okay. Now that model will process any new unknown data. If I give any unknown data to the machine, it will tell you whether it will return true or false. Is it okay? This I will call it as a model. Okay.
Yes, sir.
Understood? Yes. Now let me give you the definition of a model from your textbook. Earlier it is not from the textbook. Okay. Now models are formally structured words. Okay. That we can also call it as knowledge base. Okay. That means whatever we are going to give input to the agent, that we will call it as a model. Okay. Later I will go to live example. Okay. Whatever I am going to do since 10 years, I will discuss this example. Okay. The models are structured words. Okay. Now in this example, could you please tell me what is a model out of 8 environments? Can I call this as a model? In knowledge base, one example. Can I call these three as a model?
Yes, sir.
Now, whatever model it is returning true, out of 8 environments, only these 3 environments are returning true. So I call them these 3 as knowledge base, and I have represented with red non-linear shape. Is it okay? This I will call it as model. Okay. Now, other than this, my model will not do anything. Okay. Other than these instructions, if you ask me this, my model will not return either true or false. If you give anything in these 3 environments, my model will give you correct predictions. Is it okay? Now, what is a model? Models are formally structured worlds with respect to which the truth value can be evaluated. Are you getting me? Now, here, am I getting the truth value? Yes or no? Models are, this is a structured world. Models are structured worlds. Okay. You can call it as a robot or a machine. Okay. It is a structured, it already got trained. Okay. Whatever you give, it will listen. Now, is it giving the truth value based on this definition?
Yes,
Models
sir.
are structured world with respect to which the truth values can be evaluated. The truth value can be either true or false. Both can be called as truth values. Okay. True is different from truth value. Okay. Which truth can be evaluated. A truth can be yes or no, true or false. For example, a simple example. Maybe yesterday I went to Omega Hospital. It is a cancer hospital. Okay. For example, I have given 100 patients database to you. Okay. Please. Here I have given 100 patients database. Okay. And I have trained a machine. Now you give me any unknown data set, maybe 101st record to me. Okay. My machine will tell that based on this knowledge, my machine will tell that whether this record is got a cancer or not, cancer record or non-cancer record. Okay. If I train my machine correctly, and condition is if I train my machine with maybe minimum we should take around 500 to 1000 records. If I train my machine with the minimum 1000 records, you give me 1000 first record or 10,000 record, my model will predict, okay, whether that record is a cancer patient or non-cancer patient. Now you understood what is a model?
Yes, sir.
Yes. Now, if we represent this model in the form of a mathematical format, please observe carefully. Okay. M is a model of a sentence alpha. If alpha is returning true in this model M, please observe carefully. M is a model of sentence alpha. If alpha is returning true in this model, then M of alpha is set of models in alpha. Now, simple observe carefully. If alpha entails knowledge base, if and only if knowledge base is in the model, then alpha will also be in the model. Are you getting me? What we are saying, if alpha is returning true in this knowledge base, model of alpha also returns true in this knowledge base. Will you agree? Still, I will give more explanation from outside example. Now, please observe carefully. Let me explain. This is a supervisor learning example. Okay, this is supervisor learning. What is supervisor? Machine learning can be classified as supervisor learning, unsupervised learning. For example, maybe because of COVID period, if I conduct an examination, I will give a question paper. Along with that, if I give a textbook also to you, or how you will feel? You will simply open the textbook. Will you answer it? Are you getting me? Could you please answer for my questions?
Yes, sir.
What is machine learning? Machine learning means now I'm going to train my model using a guru, using some sort of guru or algorithm. Okay. What I'm saying, simple example is if you take Arjuna from Mahabharata, he has a guru called Dronacharya. Okay. Arjuna learned everything archery from Dronacharya D. This kind of learning is called as supervisor learning. Understood? Now there is another person called Ekalavya. Did you heard about Ekalavya in Mahabharata?
Yes, sir.
Yes, sir.
Ekalavya also learned, but without having direct guru. Dronacharya, without having guru, he learned. That I will call it as unsupervised learning. Are you getting me? A simple example to understand what is the meaning of supervised learning and unsupervised learning. Supervised learning means we are training a machine with some set of rules and regulations. Okay. Are you getting me? Now, simple example, as a student, if I conduct an examination, maybe IITs, they will conduct open book examination. Did you heard about it?
Yes, sir.
Now they will give you a question paper. Along with the question paper, they will also supply a textbook. This I will call it as supervised learning. But most of the answers may not be available. Okay, but you will get some knowledge from this textbook. Is it okay? Now, shall I call it as supervised? Supervised. Now, supervised means under the supervision of somebody, we are going to create a model. Okay, that I will call it a supervised learning. Is it okay? Now, shall I explain?
Yes, sir.
Now, let me explain with a data set, live data set. Give me 1 minute. Just observe this Excel sheet. Excel sheet is visible. This Excel sheet is visible to you?
Yes, sir.
Yes.
Now, just wait. I will take a simple bank example. Okay. If you are a bank manager, okay, I am asking you to provide a loan. Okay. Now, that means you are providing, you are a manager. You can take a decision whether you provide a loan, yes or no. Okay. Shall I call it as binary classification? Now, loan can be provided based on these features. Gender. Some people will come to you as you are a bank manager, as a some person. He may be male or female, married. He may be married or unmarried. Number of dependencies, number of children, education. Either it can be graduate, undergraduate, self-employed, unemployed. Applicant income. He may have some income, and his wife is also working. Co-applicant income. Loan amount. How much loan he is asking? He is asking for 5 years or 20 years. His credit history is good or bad, and based on his properties, he has some properties in urban area, semi-urban area, rural. Now I will call these as properties. Please, I will ask a small question. If you take a database, all the records of the particular all the columns of a record are dependent upon the primary key. Yes or no?
Yes, sir.
Now, if I know the primary key, can I get all the data of that record? Yes or no?
Yes, sir.
Yes, yes. In machine learning, we will call them as, this is called as target feature. In databases, you call them as target feature. Okay, then primary key. Okay. Now, based on this data, I wanted to know loan prediction. Okay, manager has to take a decision whether the loan has been approved or not. Now I have shown a diagram, decision machine. Okay, I will give you some tens of thousands of records. Now I will show you some records. Okay, based on those records, based on this data, whether the loan has been approved or not. Okay, now on what basis the manager will take a decision? He will see all these records, credit history, that we will call it a CIBIL score. Okay, whether previously does he has any loans, is he paying correctly or not, how much amount he is earning, how much amount he wants to get a loan. All these things will be taken care by the manager. Is it okay? Hello?
Yes, sir.
Based on these features, now I will call these features as, please observe carefully, I will call these features as independent features, and loan status I will call them as dependent features, because all these features are dependent upon loan status. Are you getting me?
Yes, sir.
Yes, sir.
Now, I'm going to apply this mechanism in our live example. Let me share the window. Maybe clumsy for today. If you now please observe carefully. Now let me draw everything. For example, if I have 100 records, database or dataset, I have 100 records. Observe carefully. All these are input features: loan amount, income, married, yes or no. This is here I will call it as loan status. Okay, loan status, it is either true or false. Okay, we have some records, hundreds of records, hundreds and thousands of records. Okay, all these are called as independent feature. This is a dependent feature. Okay, also called as target feature. Now these features are dependent upon this feature, so I will call this as target. Now look at here. Now out of 100 records, what I'm doing is 80 records or 75 records I'm using to train a machine. Okay, training. Unless you feel that you are a Rajnikant, you are training a machine, a chitti. That machine name is chitti. Okay, please. What I mean to say is I wanted to clear what is a model. Okay, now if you out of 100 records, 80 records I have taken for training this machine, training. 20 records I will use it for 20% records I will use it for testing whether machine is correctly working or not. Okay, are you getting me? Now my database consisting of labels. Okay, now yes or no, I will call them as labels. Now look at here, trained data. Shall I take this area as trained data? Please observe carefully. And shall I take this as labels? Label means for that row, label can be provided yes or no. Okay, hello.
Yes, sir.
Now I will try to extract some features. This will be the next, maybe for next semester topic. We will see it later. Okay, extraction of knowledge base. Now what I'm doing is I'm training the model. Okay, I'm training the model from this 80% of the records. Now once if I create a model, is nothing but knowledge base. Once if I create a model, okay, knowledge base, then what I will do is here I am taking either new data set I am taking. I am asking my machine, please observe here. I am asking my data to check whether loan can be provided for this record or not. Okay. Now what this model is doing is this model takes this record, please. This model takes this record and it will do some operations. It will do some inference mechanisms. Okay, and it will give you a label. Loan can be provided yes or no. Now what I mean to say is what is the necessary of model in knowledge base. That for the purpose I am teaching all these things. Okay, now you understood what is a model. Sir, you can ask one question. Sorry, in Robo movie there is a scene. Okay, one girl is maybe one building will be fire accident. One lady she is taking. Now this robo will go there and she saves her. Did you observe it carefully in that movie?
Yes, sir.
Now villain is proving, villain says that the robo is not working by showing that example. Did you got that example?
Yes, sir.
Now if you want to test your model if it is working or not, anyway we have 20% of records now. This 20% by you can test your model whether you have created the model or not. This is called as evaluation. Okay, this is called as, yes please 1 minute, Gopal is calling. Hello, చెప్పు. వచ్చాను లేదు కింద నేను ఇక్కడ ఉన్నాను అనమాట, క్లాస్ చెప్తున్నాను. నేను సంతకం పెట్టాను పైన. క్లాస్ వచ్చాక చెప్తాను. ఓకే, హలో. Now please give me a minute. Now if you want to test the model, you have around 20% records. That 20% records we are going to use this whether the model is working or not. Okay, now what I mean to, now in this example also we are taking unknown data. We are checking whether this new sentence is returning true or false. In my machine learning also I am applying this new data to this model. Okay, what this model is returning? The truth value. Okay, always models will infer the data. For now you observe it carefully. Now this is called what is model. Okay, now I will wait for 2 to 3 minutes. If you have any doubts about model, I will go. These are not from the textbooks. This I have taken from outside. This I have taken from outside to give you what is a model. Simple definition is models are structured words. Models are structured words. They will, with respect to the truth values, can be evaluated. Okay, here I am getting the truth value either yes or no. Here also I am getting truth value. Truth value, for example, it depends up. Truth value depends upon the domain knowledge. If I take insurance agent. Depending upon the calamity, insurance can be provided, insurance can be rejected. Okay, are you getting me? Now, did you understand what is a model?
Yes, sir.
Now, I'll give you 2 to 3 fast definitions about validity. A sentence is valid if it is true in all models. Please, what is the meaning of validity? Okay, a sentence is valid if it is true in all models. Okay, for example, if you take this old knowledge base, I cannot call now it is valid if my sentence is valid in all environments, then I will call it as valid. Okay, now I'll call that model as valid. Now, can I call my model as valid in a real example? Yes or no?
Yes, sir.
What is my question? You are saying yes. Can I call my model yes, valid or not? If a sentence is valid in all models, if it is true in all models, then only we will call it as valid. Otherwise, we will call it as a sentence is satisfiable if it is true in some models. If the sentence is valid in only some models, I will call it as satisfiable. There are 2 definitions. A sentence is valid if it is true in all models, then it is called as valid. Whereas, if a sentence is satisfiable if it is only true in only some models, this knowledge base, this is true in only these 3 cases only it is true, then shall I call it as valid or shall I call it as satisfiable?
Satisfiable.
That's what I am asking. Kindly understand my pain. What is my question is, what is the meaning of validity? Observe carefully. A sentence is valid if it is true in all models. Okay, if you take 8 environments, all 8 environments are returning true, then I will call it as valid. Okay, if it is satisfying only 3 or 4 environments, that I will call it as satisfiability. Okay, a sentence is satisfiable if it is true in some models. Some means it can be 1, it can be 2, it can be 7. Okay, now that can be represented, please. The definition can be represented in the syntax like this. Now look at here. A or negation A. Could you please tell me what would be the answer for this?
True, sir.
True. Here, if it is true, implication is also true. Are you getting me?
Yes, sir.
Now, here this we don't know. Okay, it has to be solved. Okay, that I will discuss it. Okay. Now look at here. Now, please, you already know it. If alpha entails knowledge base, if and only if alpha is valid, the valid in all the environments of knowledge base is valid. Okay, understood? This we have already done. Alpha entails knowledge base means if alpha is true, then knowledge base also true in all environments. Then what is satisfiable? Could you please tell me what would be the answer for A or B? Either maybe in some words it is written true, in some words it may be written false. Shall I call it as A or B?
Yes, sir.
Now look at here. A sentence is unsatisfiable if it is true in no models. For example, okay, I have taken 3 Boolean and with 8 expressions. Okay, I have 3 variables. I will get 8 expressions from this example. Okay, 8 possible models. If all these 8 models are returning false, are you getting me? If all these 8 models are returning false, then what I have to do? It is, and shall I call it as unsatisfiable? Please. Shall I call it as unsatisfiable?
Yes, sir.
For example, please observe a simple, these definitions are very important for understanding the next examples. Simple, valid means if you have 10 environments, if all 10 if your model is fixed environment, okay, if your model is false in all environments, that we will call it as unsatisfiable. Is it okay? Clear?
Yes, sir.
Yes, sir.
It can be represented as A and negation A. Okay, this is unsatisfiable. Now I need these inputs to get to the next topic, please. Now observe carefully. Logical equivalence. Now, for example, if two sentences are logical equivalent, they can be denoted as alpha. Earlier we used to call it as congruent. Na? If you write like this, shall I call it as congruent in your mathematics? Hello? If two sentences are logically equivalent, then we can represent like this. If they are true with same model, please. Now here also I am using same model, here also I am using same models. If they are, now how can you say that this alpha and beta are equal? Now please observe carefully. Beta, alpha entails beta. Okay, earlier we have already discussed that knowledge base entails alpha. Now if you want to call the two sentences are logically equivalent, that means beta entails alpha. That means wherever beta is true, there alpha is true. Now alpha also entails B. Then we can call it as logically equivalent. Is it okay? I will wait for 1 minute. Could you please tell me whether it is okay or not? Two sentences are logically equivalent. They can be denoted as alpha with equivalent to beta. If and only if beta entails alpha and alpha entails beta. If this rule satisfies, we will call them as logical equivalence.
Yes, sir.
Please. Now, from these equivalences, from these formulas may be valid, satisfiable, unsatisfiable, we are getting these equations. Observe carefully. You know all these formulas: commutative law, associative law, and Dimorgan laws and distributive laws. I think I'm in discrete mathematics. If you say, I will go for now. Everybody, please open notebook and pen. We are going to solve problems. CNF formulas. Shall I move? I think most of you know about them now. Shall I go?
Yes, sir.
Please, everybody open your notebook and test. Notebook and pen, please. Very, very important. Open. Let me explain. I wanted to introduce a new inference mechanism called as modus ponens. Are you getting me? Shall I move? For example, if P implies Q, please. The rule is P implies Q, and I have a rule. If I have and symbol between them, P implies Q and P, always it is going to return Q. Please, I am going to use this formula, please, in my next CNF and DNF equations. This rule is called as one inference rule, also called as modus ponens. Now, let me discuss a simple. Now, please take this equation. If P implies Q, are you getting me? If P implies Q and P, this is one preposition and this is another preposition. Now, if I have and symbol between them, my result will be Q. Clear? How can you say that, sir, it is Q? My explanation is P implies Q can be written as, can I write like this? Negation P or Q?
Yes, sir.
Hello? This I have already discussed in the previous examples. Here I discussed it. Are you getting me?
Yes, sir.
Please take this formula, modus ponens, that we are going to use in the next examples. The rule is, if P implies Q, okay, this is one preposition. Okay, another preposition is P. If I have and symbol between them, the result will be Q. This rule can be called as modus ponens. It can be used as an inference mechanism. Okay. Now, P implies Q can be represented as negation P RQ. Okay. Here I have, if I represent like this, negation P, RQ, and P. What happens? If you remove these two, Q will be there. That is what we got. Conjoint with, here we are going to use two terms. Here I am going to discuss about what is conjoint and disjoint here. Okay. Here I am going to discuss them. Now, give me 2 minutes time. Now, it can be represented as conjoint with P. P and now P and plus Q can be written as negation P RQ. Okay. Now this both will become false. P and negation P will become false. Will you agree? If you take associative law, and what is remaining? Q. Is it same? Hello?
Yes, sir.
Are we getting Q like this? I'm deriving Q. Actually speaking, you should remember directly like this. Okay. Wherever there is a P implies Q and P, we are going to represent with Q in the next coming solution, problem solutions. Now, did you understand? This rule is called as modus ponens. Is it okay?
Yes, sir.
Now, shall I move? Now, I will give a simple example from this equation. Okay. Now, here my example is P, it is the month of July. This is one preposition. Q, simply it rhymes. Now, I am proposing an equation sentence R equal to P implies Q. Please observe carefully. Now, I have given a sentence. You have to observe. If it is the month of July, please observe carefully. If it is the month of July, then rhymes. Now, how can I write it? Can I write it as P implies Q? Yes or no?
Yes, sir.
If it is the month of July, it is Q, P. Now, then it rhymes, it is Q. Is it P implies Q? Then it is the month of July. Shall I call it as Q? Now, if I write, is it a modus ponens formula? P implies Q and Q. Then what would be your conclusion? What is your conclusion? ఇంత దారుణం బిహేవియర్ నాకు చాలా బాధేస్తున్నారు, నాకు ఏడిపించేస్తున్నారు అది. Here I have given that it is the month of July is P. It rains is Q. Here I have represented that P and P implies Q. Here I have represented that Q. I am asking that P implies Q and Q. What would be the answer?
So P implies Q and Q is P. But then here it is P implies Q and P, no, sir. In the
What
month of July is P, no, sir.
Just wait. I will try to arrange it. Tell me, is it P?
Yes, sir.
Now, is it Q? Now, you represent this sentence. Represent this sentence. If the month is July, then rains. How can you represent? Is it P implies Q? Yes or no?
Yes, sir.
Now, it is the month of July. It is P.
Yes, sir.
Now, P implies Q and P. What is the answer?
Q, sir.
It is Q. So, it rhymes. Understood? Is it a modus ponens?
Yes, sir.
Yes, that's what I'm asking. Did I written any wrong?
Yes, sir. You read instead of P, you wrote Q, sir.
Okay, sorry. It is the formula for modus ponens. In the examination, they will ask you like this. Okay, they will give you some sentences, and you should use this formula. Okay, here we have derived also this formula. This is called as modus ponens. Next, chain rule. Okay, please. With this, we are going to close the basics. I will go to examples. Now, please, you know this formula. Okay, if P then Q, please. If Q then R, shall I write like this? P implies R directly. Remember?
Yes, sir.
If P then Q then R. Now, shall I direct like the P implies R?
Yes, sir.
This is called as chain rule. That's it. Clear? I think we have done it. A implies B, B implies C. Directly A implies C. This is called as chain rule. Okay. Why I'm saying? Because all these I'm going to use in the next coming examples in the knowledge representation. Now with this, the basics are completed. Okay, I think you know about all these because Dimorgan laws, then associative laws, distributive laws, modus ponens, chain rules. These are we are going to use in the next examples. Now, everyone, please have a heading. Please have a heading. Causal form. Please have a heading. Causal form. Okay, this is very, very important. To put 3 star symbols for this topic. You will get an example within the examination. Causal form. Now, I want to define 2 terminologies. What is a literal? Please, shall I go? Hello?
Yes, sir.
Yes.
Sir.
Yes, yes. What is a literal, please? A literal can be any atomic sentence. For example, if I take A as one sentence, negation A is also one atomic, please. Now, this can be literal. Okay, A can be one literal, negation A is also a literal. The definition of a literal is a literal is atomic sentence, or it can be called as a preposition. Okay, or negation of an atomic. This is called as literal. What is the atomic sentence? Okay. Hello. Hello. A literal can be any preposition and its negation. Any preposition and its negation of the preposition can be taken as literal. Is it okay?
Okay, sir.
Yes, sir.
Now, second one is class. What is a class? Please observe carefully. Now, let me define. Okay. A class can be called as disjunction of literals. For example, if I have literal P and literal Q. Now, R symbol can be called as disjunction. Okay, R symbol can be called as disjunction, and symbol can be called as conjunction in preposition logic. Okay, and symbol is also called as a disjunction, and R symbol can be called as a disjunction, and symbol can be called as conjunction. Now, what is a class? A class is a collection of disjunction of literals. For example, if you look at here carefully, please observe here. Now, if I call A is one preposition, negation B is another preposition. Now I am combining these 2 literals with the disjunction. Now shall I call it as a class? This is one class. You look at here, this is one disjunction, this is another disjunction. This here I have preposition 1, preposition 2, preposition 3. These 3 prepositions are attached with a disjunction. Now shall I call it as a class? Hello?
Yes, sir.
Once again. Okay, class nothing but disjunction of literals. Here, disjunction can be called as R symbol. Now, I will call it as one class. Will you agree? Now, shall I call this as a class? Is it as a disjunction of literals? Wherever there is an R symbol, that I will call it as disjunction.
Yes, sir.
Disjunction of literals or disjunction of prepositions. Now, I will call this as class 1. Okay, please. I will call this as class 2. Let's observe, please give me 1 minute time. If I combine one or more clauses with and symbol, that I will call it as CNF, conjunctive normal form. Okay, observe carefully. Conjunction of disjunction of literals. Please observe carefully. This is the conjunction. I am applying and between 2 conjunction. This is one conjunction C1 and this is another conjunction C2. Okay, now this conjunction C1 and C2 are attached with the these 2 disjunction are attached with a conjunction and. So I shall I call it as conjunctive normal form? Hello?
Yes, sir. We can call it.
Yes, yes. Thank you. I think you have this knowledge in discrete mathematics. Now, shall I go to solve one problem?
Yes, sir.
Yes.
Yes.
Yes, please. Please take this, everyone. Two subheadings: converting compound preposition into clausal forms, or within brackets write down converting prepositions into CNF. and take an example has given as negation of A implies B or C implies A. This is the question they have given. In the exams also you will get this kind of questions in the mid as well as in the externals. Everyone taken the sentence? Now shall I go for explanation? Hello?
Yes, sir. Yes, sir.
Now, please
Yes,
observe. Yeah, please. What would be the first step is whenever you have implication or by implication, please. Wherever there is an implication, first you have to remove it. There is an implication. There is an implication. You have to remove it. Now, A implication B can be written as negation of A or B. Can I write like this? Will you agree? This A implication B, I will write it as, hello? Can I write this A implication of B like this? Can I write this A implication of B as negation of A or negation of B? Can I
Yes,
write?
sir.
Yes, yes. So please take the first step. Eliminate the implication sign. Now, how I have written it? A implication be written as negation of A or B. C implies A can be written as negation of C or A. Please. This is first step. We have removed the implications. Step 1, please. If the step 1 is completed, you please tell me. Hello?
Done, sir.
Yeah, please. Yeah. The first step we have done. Second step is we have to remove the negations, please. Eliminate the double negations. Okay. Now, here we have negations now. Negation of negation. Now, is it a Dimorgan law? Negation of negation of A or B. Now, could you please tell me how it will be changed? Negation of A or negation of B. Can I write like this? Hello?
Yes, sir.
Yes, yes. Please,
Yeah.
please take this. Now, please take this. Now, here we have double negation. So, we will get directly A and negation B. It will become A and negation B, the first one. Okay, please take this. Second step is we have to eliminate negations using Dimorgan's law. Okay. Now, the first step can be converted into like this. Here we have applied, by applying Dimorgan's laws, we got this result. Step 2 is okay. Now, once again, please. This can be transformed as negation of negation. It will become A. Okay. As for Dimorgan's laws, R will become and this B will become negation B. Isn't it? Now, how it will be changed? Hello? Same thing. I have represented like this. Okay. A, R and B. Second one is negation of C or A. Okay. Is it up to here? Is it okay?
Yes, sir.
Now, can I apply distributive law for this? I have this statement. Can I apply distributive law? A or negation of C or A. Can I write like this? A or, please. Can I write distributive law like this? A or negation of C or A?
Yes, sir. We do.
And negation of B or negation of CA? Now, please take this. Here I have applied distribution law up to here. Please take only up to here. Convert this step 2 into distributive law. Now, you will get like this. Step, is it completed? Hello?
Yes, sir. Completed.
Yeah. Then associative law. If you use associative law, here what we have here? A or negation C or A. It can I write like this? It is as it is. It is as it is. There is no change. Can I write this? Can I write like this? Hello?
Yes, sir. We can.
Yes, yes. Now observe carefully. Is it a disjunction? Shall I call it as a class?
Yes, sir. We do.
Now, yes. Now, shall I call this as one disjunction? This entire thing. This disjunction I will call it as class 1. This disjunction I will call it as class 2. Now, observe carefully. Now, we are attaching these two clauses using conjunction. Now, shall I call this total sentence as conjunction of disjunction normal form? Conjunction of disjunction of letters? Can I call it?
Yes, sir.
Yes. Now, we got this. Now, if you have any compound statements, first you should learn how to convert it into CNF. Okay? This is now, it is available in the form of CNF format. CNF is input for the next very, very important concept called resolution. Very, very important. Now, you know how to convert a compound set of statements into CNF? If I ask a question, will you answer for me? Hello?
Yes, sir.
Now, please let me go to a new topic. Later, we will go it later. Now, here, observe it carefully. If you have a sentence like this, A implies B. Please take this information. Please take this syntax. Please take this. If I have sentence like A double implies B, it can be written as A implies B and B implies A. Please note this. I will tell you why we are discussing this topic. Okay? Hello?
Yes, sir.
Hello? Now,
Yes.
is it completed?
Yes, sir.
Now, please go back to the earlier example. Please go back to the earlier example. Actually, my next topic is resolution. For my resolution, please observe carefully. My input is like this. If I want to go for resolution, the data must be in CNF. Okay, this is my next topic, resolution. If I want to discuss about resolution, you should know about how to convert your compound set of statements into CNF. This is CNF, conjunctive normal forms. Okay, so what you do is, tomorrow we'll discuss about resolution. Now, what you do is, take the same example. Here you use double implies and tell me the answer. Okay, will you do it? Hello?
Yes, sir.
Yes, you do it for tomorrow as an exercise. Okay,
Okay.
Amma, this is very, very important for us. Now, they may give you by implication or they may give you implication. If you use by implication, you should use that formula. Okay, if you have by implication, you should convert it like this. Like first you have to convert by implication into simple implication. Okay, like this. Whereas if they have given compound statements in the form of simple implication, and directly you can go for like this: negation of A or B. You can use directly this form. Okay. They can give you either implication or by implication. Ultimately, you should convert that equation into CNF. You should be in such a way that always you should get disjunctive forms. Disjunctive is nothing but R symbol. You should have only R symbols between the prepositions. Now, I will call this A as literal, C, negation C as literal, negation B as literal, negation C as literal, and A as literal. And I will call this composition statements as conjunction of disjunctive forms. Understood? Hello? Yeah. With this, today we will conclude. Tomorrow, we will start a new topic, very, very important. Don't absent for class. It is very, very important. Peter? Sir, can I take the screenshot? If you have doubts, you can ask me.
No doubt, sir.
Yeah, thank you. You can leave. I have taken the screenshot. Thank you very much. Thank you very much. Thank you. Shall I leave?